All right, just some reminders, okay? I am out Monday, Tuesday, Wednesday following Thanksgiving break because I am taking our Beta Club kiddos to state convention, okay?
Congratulations.
Thanks. There will be videos posted, okay, for all of your notes. You'll notice that this packet is not long at all, okay? I'm going to get through as much as I can right here today, but I do want to make sure that you remember you are responsible for getting these notes when I am away, okay? You are responsible for making sure that all of those homeworks are complete by December 4th. That's a Thursday. The quiz is on Friday, December 5th, okay? So, we have just talked about exponential expressions, functions, equations. Now we are going to talk about logarithmic expressions, functions, equations. Now, Algebra 2 is currently working on this, so I know you've seen it before. It might have just been since last year about this time, okay? So, a logarithm is the inverse function of an exponential function. So what do inverses do to each other? Okay, they cancel each other out. They undo what has been done. Okay, so addition and subtraction, multiplication and division, logarithm and exponential. Those things are inverses of one another. Okay, so the first thing I want to do, I want to look at a logarithmic function. This says log base b of a equals x. Okay, that's how we read it. And to put it in exponential form, I'm going to draw an E. Watch this. I'm going to start with my base. I'm going to go through my X, and then I'm going to go over there to the A. The order that I touch these things is the order that I will rewrite them in. So this is log base B. So the B becomes the base of my exponential. This is going to be b to the x power is equal to a. So I just draw this little e, the little loop-de-loop, to help me with my order, okay? So let's start out just converting. Short, sweet, and simple as that, okay? I am starting with my base. Here my base is 3. I'm going to say 3 to the second power equals 9. Do you agree that that's a true statement? Okay. All right. I'm going to rewrite this in exponential form. This is 6 to the third power equals 216. Once again, that is a true statement. Okay. Then, here we go. 7 to the 0 power is 1. Now, this right here is an important exponent rule that we need to make sure we remember. Anything to the 0 power is 1. Right here, 2 to the 4th power is 16. 4 to the negative 2 power is 1 over 16. Now, I do recall yesterday we did look at these when we were converting things from a fraction to we don't like fractions, right? So we want to rewrite it with a different base and bring that up from the denominator, okay? All right, and then right here I end up with a fraction. This is 9 to the 3/2 power equals 27. Okay, now in my world, okay, I have a little trick for writing it in logarithmic form. So to undo exponential form and putting it in logarithmic form, I'm going to draw an L. It's almost like I'm drawing like the block letter base of an L. I'm going to start with the base. I'm going to come around to what it equaled, and then I will end with the exponent. Okay? So I'm just going to draw through all of these real quick and then I'll rewrite them. So guys, this right here, we are putting it in logarithmic form. So I want to have a log, and then my base of the exponential becomes the little teeny tiny base of the logarithm. The next thing that I touched was that what it was set equal to, so the 196, and that equals the exponent, which is 2. So just kind of reversing the formats. Here I would have log base 3 of 81 equals 4. What would this next one be? We know we'll start with a log. Log base 12, okay. Of 12 equals 1. All right, now, this is another property right here that I want to make sure that I know. Okay, this is a special property of logarithms. Anytime you are taking the log with a base, and the base itself is that big number right there, they cancel each other out, and they equal 1. So log base b of b is equal to 1. Anytime these two numbers are the same, it's kind of like they're undoing each other. Okay, so this one, let's keep moving on. Log base 36 of 6 is 1/2. All right, you do the next two. Let's see if y'all get the same thing that I get. I'm going to pull my paper away. You can work through it with your seat partner if you want to check before I put mine up here. Okay, you got it? What you think?
Log 2 of 1 over 8 equals.
Perfect. Log base 2 of 1/8 equals -3. And then I got log base 8 of 16 equals 4/3. I'm not calculating anything right there. I'm just rewriting. Okay? I know, right? All right. Let's take a look at page number 7. Okay, let's talk about some notation of some special logarithms. Okay? Now, a common logarithm, it's a logarithm with base 10. Okay? It can be written, if I have log base 10 of x, I want you guys to know and recognize that if I just write log of x, there is an understood but unwritten base of 10. Okay? That is the understood part. Kind of like a square root with a 2 in the index, or an x with a 1 as the coefficient. Okay? All right. Then right here, what is the natural base e? Like pi, e is a special number discovered in math and occurs in real-world applications like bank accounts and interest. Things that will matter to you beyond high school. Okay? Now, e is an irrational number with an approximate value of 2.718. Now, what we know about irrational numbers is that they do not ever end and they do not repeat with some sort of special pattern. Okay? This is just what we round e to. E is no longer a variable for you. It is a number, just like I. Okay? All right. A natural logarithm A natural logarithm is a logarithm with a base e, and it is written like this. We've got log base e of x. But because we're mathematicians, and I'm including you in that, as you shake your head over there, okay, right here, we do have abbreviations, okay? So rather than saying log base e, on the calculator, here's the log button. Directly below that, I have ln, and that's for my natural logarithm. So we're just going to rename log base e as ln. You know, because y'all know we as mathematicians like to make up our own rules. Y'all are nodding to that. We do make things happen sometimes. Okay? But our decisions are logical. All right. Evaluating logarithms, okay? It says use your knowledge of exponents to evaluate the following logarithms. Now, anytime I'm asked to evaluate, it makes sense that I need to set it equal to something or represent that I'm solving for something, okay? So here, I want to know the exponent that is going to make each one of these a true statement, okay? Now, I don't read things well in log form, okay? I want to convert these into exponential form. So I'm going to rewrite this as 7 to the x power equals 49. Looking at it this way, we should be able to pretty easily determine what the value of x is that makes that true. What is that number? 2. So all of this stuff, the log base 7 of 49 just turns into a 2. 2's prettier than log base 7 of 49, isn't it? Y'all can talk to me, it's okay. Okay. All right, here we go. I'm going to rewrite this one. 3 to the x power equals 27. Okay. Right here, what power would I raise 3 to give me 27? The third power. Okay. Do y'all remember for number 15, what is understood but unwritten? There's an understood base of 10 right here. So I'm going to convert this to exponential form. And what value of x makes that true? 10. Hold on. 2. Yeah. 10 to the second power is 100. Okay? Then I have 12 to the x power equals 1. 0. Yes. Remember, anything to the 0 power is 1. Great job. All right. 2 to the x power equals 64. What power do I need to raise 2 to be 64?
8.
Oh, careful. Okay, so you got 2 times 2, which is 4, times another 2, which is 8, times another 2, which is 16, times another 2, which is 32, and 32 times 2 is 64. So that should be 6. Now remember, raising something to a power is not the same thing as multiplying it by that number, right? That's how many times that base is a factor. Okay? All right, so we might need a calculator here to help us play around with the next one. There should be some calculators around the room. There's some more over here. Okay, don't shout any answers out, but play around with this for a few moments and see if you can figure out what my exponent would need to be here. Don't shout anything out. Give everybody just a minute.
No.
You see what it is? All right, what'd you get?
Wait a minute.
5. Okay, the answer is 5. All right, 3 times 3 is 9, times another 3 is 27, times another 3 is 81, and 81 times 3 is 243. Okay? All right, hey, you are fine if you want a calculator, okay? Not all of these are easy numbers to work with. What you got?
-6.
Okay, -2, good. Remember, we can have negative values. I got you. Go ahead. Okay? All right, what about this last one? I got 64 to the x power equals 4. Hey, real quick, my number went from a bigger number to a smaller number this time, right?
Yeah.
So think backwards. What power would I raise 4 to give me 64? Close. The third power, okay? Now, if I am going from a bigger number to a smaller number, that gets flipped. So it's 1/3. That means I would be taking the cube root of it. Raising something to the 1/3 power is the same thing as taking the cube root. Okay? All right. Now, some of our calculators don't have the capability of typing in like log base 2 of 16 to get an answer. So what people figured out in the past is that we can do what we call this change of base formula. So right here, we have log base b of a. I don't know what that is beside it, but that should just be an a, okay? We are going to create a fraction where I am converting both of those into a log base 10. I'm going to do log of a divided by log of b. Now, my big number is going to go up in the numerator, and my base goes to the bottom. Makes sense, right? The base, bottom. Yep, snack cart. All right, anybody? All right, guys, thank y'all for supporting them. All right, here we go. Change of base formula, okay? All right, let's lock back in, okay? Right here. I want to show you just because, okay, I want to get us used to setting this up. I am going to change this from log base 16 of 64 into log of 64 over log 16. Okay? This will be log of 32 equals log of 8. They're all full. Then I've got log of 54 divided by log of 2. Log of 294 divided by log 10. Okay. Now, right here, this is log 136 over log 4. And then just be careful when you are doing fractions. You got log of 136 over log of 6. Now, I'm not going to do all of these with you, but I want to show you when we are putting these in the calculator, okay? The calculator understands the logarithms to have a base of 10. Now, all of these are fractions, right? So I'm going to hit alpha y equals, and I'm going to choose number 1 because I want it to give me a fraction. I'm just going to do log 64, and I'm going to close up that number. It opens, hey guys, it opens parentheses, so you got to close those parentheses. Y'all sit up in the back for me, okay? Right here, I've got log of 16, and I'm going to close up that logarithm. When I hit enter, I get 1.5, which is equal to 3/2 as a fraction. What happened?
I didn't close it, but you gave it right.
Okay.
So we have to use
I would. Now, if you don't recall how to turn those decimals into fractions, or you don't automatically recognize it, do you see the math button right here underneath alpha? If you see math and you see number 1, if you want to turn it into a fraction, you'll hit enter and then enter one more time, and it will do it for you. Okay? All right, let's do the next one. Alpha y equals, I'm going to do log 32 divided by log 8. I almost said 4, but it's, oh my gosh. There we go. Okay? This gives me 1.6 repeating. Okay? Now, I recognize how to turn this into a fraction because this is 1 2/3. Okay? That turns into the fraction 5/3. But once again, if you need help with that, hit the math button. Okay? Let's look at 24 real quick. Okay? If I do log of 294 over log of 10. Okay, I'm going to get this decimal, and I'm not even going to try and turn that into a fraction. Okay, I'm just going to round this. Sometimes with your rounding, you do have to be very careful because it will mark a whole problem wrong. Okay, right here, I want to show you if I just did log 294 in the calculator and hit enter, look at what it gave me. Because what is understood to be my base, a 10, and they cancel each other out, those equal 1. So this right here is essentially saying I'm dividing by 1. Okay? Now, also, this right here could be rewritten as just log 294 because those are equivalent to each other. You don't have to write that 10. Okay? All right. Let's look at 26. Alpha y equals, I'm going to do number 1. I've got log of 1 divided by 36. Notice I just did 1/36. You could put another fraction in there if you wanted to. Okay, and then I got log of 6. And I get a pretty -2. Okay? The calculator is going to be very helpful to us here. Okay? All right. Flip over very quickly. Let's look at the top of page 8. Okay, and I want to convert between my forms again. But I want to remind you that E and the natural log are inverses of one another. Okay? Okay? Now, I want to put this in logarithmic form. So I'm going to draw my L for all of these. Okay? And order matters here. Okay? I'm going to say log base E of 24 equals X. Is the trumpet sounding? Okay, now, right here, I want to remind you that log base E is the same thing as the natural log. So I can shorthand that And this is what I would be looking for, the natural log of 24. Okay. All right, here we go. Log base e is the natural log, and I'm moving to x next, and then that will equal 9. You like that, didn't you? I'm a poet and didn't know it. Okay, here we go. Right here, the natural log of 72 is equal to x plus 5. Now, very quickly, okay, if I were asking you to solve for x, if I wanted x all by itself, what would I need to do to move that plus 5 away? Okay? Yes, we're going to subtract. Now look, right here, I've got the natural log, and when I put the natural log in a calculator, please remember that it opens parentheses. So we have to close those parentheses, and then I will have minus 5 out behind that. Okay? Yes.
Can I make the arrow lowercase for us?
Yeah, that's fine. Whatever works for you. Okay, all right. Here we go. Now I want to convert these into exponential form. What is the understood but unwritten base of all of these? Whoa, this is the natural log. Log base E, the natural log. So there's an understood but unwritten base of E for all of these. Okay? So to convert them to exponential form, I'm going to say e to the 58th power equals x. Here, e to the x power equals 6. And then e to the 32nd power equals x minus 9. Once again, y'all, if I am trying to solve for x, what do I need to do to get rid of what's with x? Move it. Now, this is e to the 32nd power, not up in the exponent. There's going to be a big old plus 9 out in the back. Okay? So when you're putting that in the calculator, when you do e to the whatever power, hey, look right here. Do y'all see the division key? And do you see right above the division key in blue, it's that little e? If I do e, and then I raise that to the 32nd power, do not just put plus 9 right there. Okay? Hit the down arrow so that then I can put a plus 9. Okay? We got to make sure that that's out in the back. Okay? 55? Okay. All right. What we're going to do, we're going to stop right there. Okay? And we're going to log in, and we're going to, at this point, listen to me. You should have enough to complete homework 24, and you have a little bit to get you started on 25.